Welcome, everybody. This is the Week 10 quiz help. What I went and did was go through the quiz and then go through the book and find 10 similar problems. The following problems are the ones that I found. There was only one that I had to create myself. Down here, there was one, I call it the extra problem. I created that myself. I couldn't find an example that was similar. Okay, so let's get straight to it. This week, if you read the instructions, there are three different ways of solving um, these problems. By the way, this week, these problems are called systems of equations. And now we're solving. In the past, we've solved for x. We found x, get x on one side, everything else the other, or we factored in, we found x. Now we're finding x and y. So this week it's a little different because we're finding x and y. And it's called a system of equations because we have more than one equation now. We're dealing with two equations. So if we have two equations, we're going to have two unknowns, two things we need to find. And in most cases, it's going to be find the x and find the y. There are three methods that we use in this system. We can solve by graphing, and we actually have one problem like that we're going to do today. We're going to solve by substitution and then solve by something called elimination or the addition method. Now, virtually every problem on here we're going to solve by using the addition method. So just about every problem on here we're going to solve by using the addition method. I'm not even going to go over the substitution method. Okay, so if I look at this first problem, I'm on page 242, example 1A. 242, example 1A. 3x minus y equals a negative 6, and x plus 2y equals 5. So we're going to solve this and this is called, well, it just depends on what the book calls it. Now, in the book, it says solve this by graphing. I'm not going to graph it. I'm going to solve this. Oh, I'm sorry. This first problem is not even a solve problem. It says determine whether negative 1, 3 is a solution. Okay, so I didn't even read the problem. It says determine if negative 1, 3 is a solution. So we want a solution means is negative 1, 3 an answer? Remember when we find a point on a graph, the x is always the first part of the coordinate. This is just a dot on the graph, negative 1, 3, and then the 3, the second part is the y. So in this coordinate, x equals negative 1 and y equals 3. So it says determine if negative 1, 3 is the solution. What we need to do is plug negative 1, 3 in each of these equations. Here's the first one. 3 times x minus y equals a negative 6. I'm going to plug in negative 1 for x and 3 for y, and I'm going to see if this is a solution. Negative 1 times 3 is negative 3. Negative 3 minus 3 is a negative 6. Negative 6 equals negative 6. This is a true statement. Okay? Now, I did it for the top, and we got a true statement. Now I want to do it for the second equation. The second equation is x plus 2 times y equals 5. X, once again, is negative 1, and y is a positive 3. Negative 1 plus 2 times 3 is 6. Remember, order of operations, you multiply before you add or subtract. Negative 1 plus 6 is 5. 5 equals 5 is also a true statement. So if you plug in the numbers into the both equations, and you get true, true. So 2 truths, and then your answer is yes, -1, 3 is a solution. So if you plug the numbers in and you end up with a true statement, well, -6 equals -6, 5 equals 5. If you end up with a true statement, 2 true statements, then you say yes, -1, 3 is a solution. If you end up with something like this, when you do the math, if you end up with like 6 equals -6, this is a false statement. That's not true. If you get one false statement, just one false, then one false statement, then it would be -1, 3 is not a solution. Okay, so this is problem 2. It says on page 245, let's just discuss the top of the graph. So I'm going to page 240. Do you have your book handy, Lisa? Okay, so I'm going to the top of page 245. And there's 3 graphs up there. And I just want to talk about those 3 graphs. What we're doing this week is we're graphing, or we're not graphing, but we're solving systems of equations. We're solving 2 equations. Each equation that we have is a straight line. So most of the graphs will be something like this. Most of the graphs will be the first graph. You see there's a blue line, and then there's a red line. The point where they cross, that's the solution. That's the answer. That's what we're looking for. That point where we cross. And each point, each coordinate on a graph has an x part and a y part. Okay? So when you have one answer, in other words, when 2 lines cross and it creates one answer, if you look at the top, these are called consistent systems. And the answer is independent. So I'm just going to write the word independent here. So when you have one answer, the answer is going to be independent. That's what we're looking for, because some of the questions on the quiz say, are they independent, dependent, or inconsistent? So when you have one answer, I'm going to write one answer. Well, this one here is just one answer. The point where they cross, you have one answer. It's called a independent system. Now, the next line, it looks like one line. The next line looks like one line. It looks like this. But it's actually 2 lines. It's one line with another line right on top of it. So the second graph is 2 lines. If you look, there's a blue and there's a red equation right on that line. There are 2 lines on top of each other. 2 lines on top of each other. In other words, you could say they're the same line. Now, the answer for this is these 2 lines are called dependent. They're called dependent. That's important. So you could have 2 lines that cross and find one point, and 2 lines that are on top of each other. That's called dependent. And then finally, you can have 2 lines that never touch. And these are 2 parallel lines. 2 parallel lines that never touch are called inconsistent. In other words, there's no answer. There's no solution. There's no points that touch. I want to go back up here. Here, there's one point that touched. There's one answer. Now, this one, if we look at that, dependent, it says there's an infinite many solutions because these two graphs are touching. Do you see? They touch at every single spot because they're right on top of each other. So this graph that's dependent has an infinite number of solutions. So it has an infinite number of solutions. Infinite number of solutions. So and you're going to have a couple of pictures, and they're going to ask you, are these independent, dependent, or inconsistent? So you need to know which are which. Independent, there's one answer. It's just two lines that touch each other, cross at one point. Dependent lines are two lines that are on top of each other. In other words, it looks like it's just one line, but it's really two lines, one on top of the other. And then the inconsistent is when you have two lines that never touch. Parallel lines will never touch each other. We okay with that? Okay, so page 258, example 1. So we're on the section that says solve using the addition method, and pretty much every problem I'm going to do is going to be solved using the addition method. So I just wanted to let you know we're going to use these same steps for just about every of the rest problems, every problem that we have. Oh, by the way, you didn't see what I did at the very beginning. At the very beginning, I have 10 questions that I'm going to go over right now. We're right here right now on the third one. These are the 10 questions. I went through the quiz and then I went through the book and I found very similar problems. Have you been watching my videos? Okay, good, good. How are they doing? Are they all right? Oh, okay. Okay, yeah. I don't know what to say. I wish I would have started this at the very beginning. I didn't, I didn't start. I didn't do these videos at like the first 5 weeks or so. I wish I would have did them then. All right, so we're going to use the addition method to solve this. In other words, we're solving. We have to find x and y. We're going to find x and y. Now, here are the steps for addition method, and we're going to use these same steps for every problem that we do. I'm going to write down the steps. Step number 1 is multiply one or both equations. So either x or y equal the same number, but one is positive and one is negative. So that's step 1. Multiply one or both equations so either x or y is equal, and I'm going to put a comma here, the same number, but one is net positive and one is negative. Then step 2, we're going to add them up. Step 2, we're going to add them going down. I'm going to write add them going down. Step 3, we're going to solve. And then step 4, plug answer from step 3 into any original problem equation and solve again. It sounds like a lot, but watch. It's really, I don't think it's going to be too bad. And so I wrote the steps down, and we're going to go over them one at a time. So step number 1, I'm looking at these two equations. This is equation 1. This is equation 2. I need to get either the x's, the numbers in front of the x's to be the same. It says multiply one or both equations so either the x or y are equal. I need to try to, I'm going to multiply the entire whole first row or second row to try to get all the x's to be the same or all the numbers in front of the y's to be the same. Do you see how the numbers in front of the y's are the same? The number in front, what's the number in front of the y? Yeah, exactly. I want you to see, do you see how the y's have the same number? Either the x's or the y's are equal. Do you see how the y's both have 1? And do you see one has to be positive and one has to be negative? One is positive and one is negative. Do you see how that's already there? So we don't have to do step 1 for this problem. See, step 1's already been done for us. So for this problem, step 1 is done. Now watch step 2. Step 2 says add them going down. Add going down. I'm just going to put a line here, and I'm going to add them. What's 2x plus 3x? Yeah, I don't want to mess this up too much. So I'm going to add them going down. I get 5x. What's 1y minus 1y? Yeah, a negative 1 and a positive 1 is 0. You see, a 1 minus 1 is 0. You could say 0y, but 0y is the same thing as saying 0. 1 minus 1 is 0. That's our goal. When we add, I should have put a goal up here. Our goal when we add, this is called the addition method. When we add, either the x's or y's have to go away. X or y have to turn to 0. So that's our goal. And we did it. Now I'm going to add these. 5 and 10 is 15. Okay, so I have 5x plus 0 is just 5x. 5x equals 15. So we just did step 2. Do you see I just added them down? Either the x or the y is going to go away. The y went away. Step 3, I have to solve for x here. Solve. How do I get rid of this 5? I want x by itself. It's 5 times, so we do the opposite of multiply. Divide. So you divide both 5 by both sides. It's a 5 multiply times x. So you divide by, I'm going to write divide. You divide by 5 to both sides. 5 divided by 5 is 1x. And 15 divided by 5 is 3. Remember, we're trying to find out what x and y equals. Here's one answer. X equals 3. So 5x equals 15. We divide both sides by 5, and x equals 3. Now, we got one answer, but see, up here we're trying to find x and y. We found x, but we need to find y now. Now, let's see the next step. The next step says plug your answer from step 3. My answer from step 3 was x equals 3. So into any original equation and solve again. So I'm going to pick any original equation. Should I pick equation 1 or equation 2? It doesn't matter which one you pick. So I'm going to pick equation 1. Or no, I'm going to pick equation 2. I think that's easier. 2x plus y equals 10. So I'm going to bring equation 2 down here. 2x plus y equals 10. This is equation 2. And I'm going to plug my 3. It says plug the answer from step 3 into any original equation. X equals 3. I'm going to plug a 3 right into there. 2 times x plus y equals 10. X is 3. So then I'm going to solve. 2 times 3 is 6. And I'm going to get the 6 to the other side. It's adding. What's the opposite of adding? Subtracting. Yeah, I hate to put you on a tough spot. I'm sorry. Normally, I try to get a couple people here, so one person's not always on the spot. So we do the opposite of adding 6. I'm going to subtract 6 to both sides. 6 minus 6 is 0. I am left with y. 10 minus 6 is 4. And here's my answer. X is 3 and y is 4. Those are my two answers. Now you can actually put it in coordinate form. Coordinate form is x and y. So if you want, you can, instead of writing x equals 3, y equals 4, you can put a 3 in the x spot, a 4 in the y spot, and this is the same as long as you have a parentheses around the coordinate. So this is the answer, or you could write, this as the answer with this. These two are the x equals 3 and y equals 4. Either one is the answer. Now we're going to use this same method over and over. So I'm going to go over these steps again, 1, 2, 3, 4, over and over again. But first I'm on page 246, example 7. I think this is the easiest problem in the whole quiz. So page 246, example 7. Let's take a look at that. Page 246, example 7. And do you see that graph right there in the middle of example 7? Okay, so let's read the problem. A lot of it's just a bunch of baloney, really. If you read the whole thing, you're going to get confused. It says monthly demand for greenie babies is given by the equation, blah, 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 while monthly supply is given by blah, 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 where X is the price of dollars. So just remember, X is the price of dollars, price in dollars. X is the price. Graph the two equations and find the equilibrium. Well, the quiz is going to give you the graph. So it's going to give you the graph. And we want to know what the equilibrium price is. So I'm going to write this down if I figure out how to spell equilibrium. Equilibrium is the point where graphs cross. So equilibrium is the point where the graphs cross. Now look at the graph. Is the price on the x-axis or the y-axis? Do you see the price? Yeah, the horizontal, it starts at 0, then it goes to 5, it goes to 10, 15, 20. That's the x-axis there. That's the price. So it says, what is the price at equilibrium? In other words, they want to know what x equals where those two lines cross. What does x equal when those two lines cross? No, see, that's the y. Y goes... So, yeah, 10 is the answer. So, what is the price when at equilibrium? The answer is x equals 10. That's all they're looking for. What is the the price at equilibrium? And the answer is x equals 10. Now, if they ask for what is the number of toys at equilibrium, then the answer would be 4,000. Do you see the number of toys is the y going up? So if they ask what is the number of toys, well, that would be the y-axis. But they ask the price, so the price is 10. So you just make sure you read what they're at. You're going to read all those equations and you think you're going to have to do something or whatever. It's what is the equilibrium price? Well, you look at the graph and it's the point where they cross. Okay, here's a little crazy. This is a crazy one. Page 260, example 4. I'm going to say this might even be the hardest one because of the fractions. This freaks people out normally. And we're going to solve using the same method we just did. But the first thing we need to do when we have fractions, when fractions multiply by the lowest common denominator. So I'm going to multiply each of these each line by the lowest common denominator. Do you know if the lowest common denominator, the denominator is 2 and the other denominator is 3 and the top fraction? Do you know what the common denominator between 2 and 3 is? If we're going to add these fractions, what's the common denominator? Yes. So I'm going to multiply this whole top row by 6. So I'm just going to put the 6 there. Now, what's the common denominator between 4 and 2? Yes, the lowest common. Now, you could have actually said 8. That's a common denominator, but 4 is the lowest common denominator. So watch what I do when I multiply. So I'm going to multiply this out. I'm going to say 6. I'm going to do the top row first. 6 times 1 half x. Then I'm going to do minus. Oh, maybe I should do this in red. No. Then I'm going to say 6 times 2/3 y equals 6 times 2. So you have to multiply 6 times each thing here. 6 has to be multiplied times each of these things. Now, 2 goes into 6. Do you see I have a 2 on the bottom and the 6 is on top? 2 goes into 6 3 times. So I'm left with 3 times 1 times x is 3x. 3 goes into 6 2 times. I'm left with 2 times 2, which is, and there's a minus sign here, minus 4y. And then 6 times 2 is 12. So when you multiply by the LCD, the common denominator, the fractions go away. So I'm going to try this one now. 4 times 1/4 x plus 4 times 1/2 y equals 4 times 6. So I'm going to multiply each of these by 4 because I distribute the 4 to each of these. That's how we clear the fractions. Now the 4's here cancel, and I'm just left with 1x, or x. 2 goes into 4 2 times. I'm left with 2y, and then 4 times 2, or 4 times 6 is 24. So here are my two equations. So I'm going to write those down. Ooh, I'm running out of room. Let me see if I can do this. I'm going to make some more room. There we go. Made some more room. So I have my two equations, and I'm bringing them down to the next page. So I can 3x minus 4y equals 12. 3x. Let me get it over here. I got it in the wrong spot. 3x minus 4y equals 12. I hope I wrote that down right. 3x minus 4y equals, and x plus 2y equals 24. X plus 2y equals 24. So that was the first step. We got rid of the fractions. Now we're going to go through our process. Step 1, we're going to multiply one or both rows. So we get the same number, and one's positive and one's negative. I'm going to multiply one or both rows. Now, do you see the x's and the y's? Which one can I make the same and different signs? Which one should I try to do? You could either do the x's or the y's. I want to get the same number but different signs. What should I try to get the same, the x's or the y's? You could, me personally, yeah. It doesn't matter. I'm gonna do the y's. Do you see I have one negative already and one positive? Remember, we have to have one minus and one plus. So if you watch what I do, and I just have to figure out how to get I have a 4 here and I have a 2 here. All I have to do is try to get these numbers the same. How do I get the numbers the same? What can I multiply by to get the numbers the same? Watch what I do. Yeah, I'm going to multiply just the bottom row by 2. Remember I said you can multiply one or both rows. I'm going to multiply the bottom row by 2. Watch what happens. 2 times x is, I really wanted to put it over here. 2 times x is 2x. 2 times 2y is a positive 4y. And 2 times 24 is 48. Now, I'm not going to multiply the top row. 3x minus 4y equals 12. Do you see how I have the same y's? One's positive and one's negative. You okay with that? See, I just multiplied the bottom 2, and then we got the 4's to be the same. One is positive, one's negative. Now, if we do step 2, add going down, we're going to add them up going down. 3x plus 2x is 5x. 4y minus 4y, 0. And 12 plus 48, see, we're going to add going down. 12 plus 48 is 60. I'm left with 5x equals 60. Step 3 was solve for x, solve for whatever's missing. This is 5 times x. How do I get it to the other side? Do the opposite of multiply, which is divide. So it's 5 times. The only way to get rid of the 5 is do the opposite. I'm going to divide both sides by 5. And I'm left with x equals 12. So there's one answer, x equals 12. I have to find y now. Step 4 was pick any original equation and plug in answer from step 3. So I'm going to pick any original equation. I'm just going to pick this one, the second one. It doesn't matter which one you pick. So this is step 4. X plus 2y equals 24. So I have x plus 2y equals 24. And my x is 12, so I'm going to put a 12 in there. 12 plus 2y equals 24. So I'm putting the 12 in there. Okay, now I'm solving for, see, we just put it in there. So now I want to get y by itself. I have to get rid of the 12, and I have to get rid of the 2. When you're solving for x, you always get rid of the add or subtract first. This is multiplying. This is adding to this side. So we're going to do the opposite. We're going to subtract 12 to both sides. 12 minus 12 is 0. I'm left with 2y equals 12. And now I need to get rid of the 2. It's multiplying times the y, so I have to do the opposite and divide by 2. 2 divided by 2 is 1y. 12 divided by 2 is 6. And there's my other answer. One answer was x equals 12. The other answer was y equals 6. You can put the answers like this, or you can write it in coordinate form where the first number is always x and the second is y. 12, 6 is the other way you can write the answer. Either way is fine. This is the answer, or this is the answer in coordinate form. So that I'm going to say that was, because we had to change the fractions, that was probably the hardest one out of the bunch. Page 261, example 5A. Okay, this is going to be fun. Okay, this is a special case. The next two problems are special, so I'm writing special up here. The next two problems are special cases. Aren't they all special? So step number one, same steps that we've been using, multiply one or both equations to try to get the x or y's the same. Now, which ones do you want to get the same, x or y's? Just pick one. It doesn't matter here. Just okay, let's get the y's the same. What row do I have to multiply something by to get them the same? Or let's just look at the y's. How can I make them the same? One is a 2 and one of them is a 1. So what do I have to do? What do I have to multiply? Yeah. Well, I need them both the same. I can't multiply it by 1. If I multiply -1 by 1, I still get -1. There we go. Exactly. So what you have to look at, okay, I have to get them both the same. So I'm going to say I'm going to multiply the top by 2. So, you have to tell yourself, how do I get them the same? I have to multiply the top by 2, and then they will be the same. Now, remember, one has to be plus and one has to be minus. They're both minus. So the only way to change the sign, instead of multiplying it by 2, I'm going to multiply it by -2. So I'm going to multiply the top by -2. And watch what happens here. -2 times 2x is -4x. -2 times a -1y. There's an invisible 1 there. Negative times a negative is a positive 2y. And then -2 times 1 is a -2. So I just multiply the top row by -2. It changed the signs of everything there also. The bottom row I'm going to leave the same. You don't have to multiply the bottom row if I have the same numbers now. Do you see? I have the same numbers for y. One's positive, one's negative. They're both 2's. The second step, step 2, add them going down. So we're going to add them going down. What's a -4 plus 4? Yeah. A +2 and a -2. And a -2 and a +2. Yeah. That's why I said this is a special case. Remember, step 2 was add them going down. Step 3, solve for x or solve for y. Well, I can't solve for x or y because the x and the y's disappeared. So that's why this is a special case. And I'm going to write this down. If the x's and y's cancel out, oh, by the way, 0 equals 0. Is this true or false? Does 0 equal 0? That's true. 0 does equal 0. 0 equals 0 is true. If the x's and y's cancel to 0 and you have a true statement, 0 equals 0, then the answer is there is an infinite number of solutions. And we looked at those two lines that were on top of each other. These are two lines that are on top of each other. There's an infinite number of solutions. If the x's and y's cancel out and you get a true statement like this, then the answer is there is an infinite number of solutions. So you actually have to write there's an infinite number of solutions. Now we're going to try the next one. It's very similar. Page 261, example 5b. It's the one right next to it. Step number 1, multiply one or both rows. Do you see how I have a positive 2 and a negative 2 for the x's? So I don't have to multiply one or both rows. Remember, our goal, is to get either the x's or y's exactly the same, opposite signs. I did that, and I'm going to put not needed here. We didn't have to do it because it's already done for us. Step 2, add going down. So I'm going to add going down. What's a negative 2 plus 2? And, oh, look at this one. A plus 3 and a minus 3. Uh-oh, now 9 plus 18. 27. So 0 plus 0 is 0. So 0 equals 27. Is this true or false? No. Yeah, because 0 does not equal 27. The question is, does 0 equal 27? No, 0 is 0. So this is a false statement because it's not 0 equals 0 exactly. So this is false. Now, just like before, if the x's and y cancel and you get a false statement this time, then the answer is there's no solution. There is no answer. So if you get a true statement, the answer is an infinite number of solutions. If you get a false statement like 0 equals 27, then there is no solution. No solution. So that one was easy because you just had to add them going down. I like that one. Page 260, example 3. So we're going to solve this and then say whether these two are independent, dependent, or consistent. So first we're going to solve them, and then we're going to find out which one of these they are. Step number 1, multiply one or both equations to get x's or y's the same, opposite signs. Now, which one do we want to get the same? The x's or the y's? It really doesn't even matter here. Let's do the x's. Okay. Now, what's the common denominator between 2 and 3? If these were fractions, 1/2 and 1/3, what's the common denominator? Okay, perfect. So you see, if I'm going to get the x's the same, I want to turn them both into 6. I'm going to find, I look at them, I say, what's their common denominator? I'm going to turn them both into 6. What do I have to multiply the top row by to get a 6 for x? What do I have to multiply the top row by to get this 2 to change into a 6? Exactly. So I'm going to multiply the top row by 3, and do you see, we want to get it turning into 6, the common denominator. Okay, what do I multiply the bottom row by to get 6 for x? So that's what I'm going to do. Did somebody else come in here? Oh, no. I thought I saw somebody else come in. So I'm going to do 3 times each of these, and then I'm going to do 2 times each of these. And oh, wait a minute. So we're going to get the x's the same, right? They'll both be 6, but one has to be negative. So Which one do I want to multiply by a negative number, the top or bottom? It really doesn't matter. Pick one. Okay, so instead of 3, I'm going to multiply the top by negative 3. Negative 3 times 2x I get is a negative 6x. Negative 3 times a positive 3y is a negative 9y. And negative 3 times 7 equals a negative 21. The bottom I multiply by 2. 2 times 3x is 6x. 2 times 4y is a positive 8y. And 2 times 10 equals 20. Now, I'm looking once again just at my x's. They both are 6's. I could care less about the y's and everything else. They both are 6's. One's positive, one's negative. If we didn't multiply by a negative number, then we wouldn't have been able to, add them going down. They have to be the same number and opposite signs. So step 2 now then will be add the numbers. Add going down. 6x minus 6x here is 0. A negative 9 and a positive 8 is a negative 1y. A negative 9 and a positive 8 is a negative 1y. And then a negative 21. Yeah, it's you could just I think it's probably easier just to write a negative y. Yes, exactly. Thanks. A negative 21 plus 20 is a negative 1. So I have a negative y equals a negative 1. The only thing I need to do now is get rid of this y. And that's why I think I left the 1 there. Because there's a negative 1 there. It's negative 1 times y. The only way to get rid of it is divide by negative 1. Because negative 1 divided by negative 1 is a positive 1y. Negative 1 divided by negative 1 is a positive 1. So y equals 1. So step 3 was solved. We just did that. And step 4, plug into original problem. I need to plug this y into any one of the original problems. Say top or bottom. Which one you want, top or bottom? Okay, so we're going to take the bottom, 3x plus 4y equals 10, and we're going to plug y equals 1 into the y spot. Yeah, the step 4, it doesn't matter which one you pick of the original. So we have 3 times x plus 4 times y equals 10, and y is 1. So I have 3x plus 4 times 1 is 4 equals 10. I need to get rid of the 4, and I need to get rid of the 3. You always do the add and subtracts first. So this is a plus 4. You have to get rid of that first because the 3 is multiplying. I'm going to minus 4 both sides. And then I'm going to divide by 3. 3 times x. So I'm going to divide by 3. 3 divided by 3 is 1x. 6 divided by 3 is 2. Here are my two answers. X equals 2. That's a little bit messy. And y equals 1. If I put it in coordinate form, the x always goes first. X is 2, y is 1. The x always goes first, and then the y is second. So these are the answers. You can write it either way. Oh, wait a minute. So do you see how I get one answer here? My answer is 2, 1. X is 2, y is 1, right? My answer is 2, 1. But we have to go back up to the original problem. It says determine if these are independent, dependent, or consistent. So, and I say go to page 245. 245 are those those 3 pictures at the top of 245. Now we have one answer. Do you see the very first graph? It says they're independent. They're exactly one solution. When you have 2 lines that cross, there's exactly one solution. So the question is this independent, dependent, or inconsistent? Well, the first graph that has exactly one solution like we have is independent. So this answer you should write not only the answer here, 2, 1, but you also have to write that they're independent. It's an independent answer. If the line was on top of each other, where there's an infinite number of solutions, then you would write dependent. On page 245, if the lines are no solution, then you would write they're inconsistent. But as long as you have one answer, they're always going to be independent. Okay, I think we have, 2 problems left. Okay, so here's a word problem that I couldn't find in the book, so I created my own. It says the sum of 2 numbers is 61. So sum means we add, right? So when I add 2 numbers, they equal to 61. So I'm going to call my 2 numbers, since we've been using x and y this whole time, I'm going to say when I add x and y, two different numbers, when I add x and y, their sum is 61. That's the first equation. Now their difference. What does difference mean? Subtract. So now I have to subtract the same 2 numbers. Their difference, in other words, x minus y equals 15. I'm going to use the same steps that I've been using. Step 1, multiply 1 or both equations to get the same number. But this is kind of important. Do you see how, and you have to have opposite signs. Do you see how I have a positive 1 and a negative 1y? So I don't have to do step 1. Don't need to do, because I have 1y and negative 1y. I have the same numbers and different signs. So for this problem, I don't have to do it. I just go to step 2. Add going down. There we go. So, what's x plus x? Remember, there's 1's in front of there. 1x plus 1x is 2x. So when you say x plus x, a lot of people don't understand that. But it's a 1x and a 1x. 1x plus 1x is 2x, exactly. Now here we have 1 minus 1. That turns to 0. And I'm going to add these, 61 plus 15, and I get 76. Okay, so I'm left with 2x equals 76. Step 3 was solve. So we got to just get the 2 to the other side. It's 2 multiplied by x. How do I get it to the other side? No, well, no. It's multiply, so you have to do the opposite, divide. When you have the number right next to x, it's a multiply, so you have to do the opposite, divide by 2. You see, you end up with 2 divided by 2 is 1x, and 76 divided by 2 is 38. So that's one answer. Step 4, plug in any one of your original problems. Any one, 1 or 2. I'm going to pick number 1. X plus y equals 61. So I'm going to take the first equation. Remember step 4, pick, original problem, and plug in whatever you got for step 3. I'm going to pick this equation. X plus y equals 61. And we're going to plug x into the equation. X is 38. We're going to plug 38 into the equation. 38 plus y equals 61. I just need to get the 38 to the other side. Now, this 38 is adding to this side. Do you see it's not multiplying times the y, it's adding. So we subtract 38 here. Subtract 38 here. And we get y equals 61 minus 38 is 23, I believe. Yeah, 23. So my 2 answers are x equals 38 and y equals 23. If you add these two up, they equal 61. If you subtract them, they equal whatever they were supposed to equal. I hope. 50. Oh, did they? Yeah, 15. No, they don't equal. That's not right. Did we do something wrong? The sum is 61. The difference is 15. 76 divided by 2, 38. Oh, 23, not 27. I put a 27 there. It's 23. Oh, that scared me. There we go. The difference between 38 and 23 is 15. And when I add them, it equals 61. So the answer is 23. I wrote 27 by accident. So the problem that you will have on the quiz is very similar to this, very similar to the setup. And the last problem, page 266, number 83. We have to be able to, page 266, number 83. Once again, we have to be able to set this problem up and then use the same method we've been doing. It says a butcher combined $4.20 per pound of hamburger with $3.10 per pound of hamburger. How many pounds of each were used to get a 100-pound mixture worth $3.76? Okay, so wow, that's not the problem that was in the book or the quiz. Let me see. How many is Yeah, I guess I have to do this one. I'm going to change the problem a little bit. I'm going to change the problem and make it look more like what's in the book. It said a butcher combined $4.20 per pound of hamburger. So that's a special kind of hamburger that costs $4.20. And I'm going to times the number of pounds. I'm going to say X is the number of pounds of that hamburger. Then they're going to add it with $3.10 hamburgers. So that's probably got more fat in it or something. Wise. And when they add it up, it says you get 100 pounds of 376 per pound. I'm going to say when you add it up, you get $376. It costs the number of pounds times 420, and then the number of pounds times 310. You add it up and it equals 376. Okay, 100 pounds times $3.76 is $376. Now you need two equations. Now it says the number of pounds of this hamburger plus the number of pounds of the other hamburger equals 100 pounds. So the second equation is the number of pounds plus the number of pounds equals the total number of pounds. So this is the two equations that we have. I wrote it kind of big. So I'm going to write it again over here. 420x plus 310y. Boy, this is not really being nice. Equals $376. And then I have x plus y equals 100. So here are my two equations. I need to do the same thing that I've been doing. Step one, multiply one or both equations to try to get the same x or y. Now I'm going to multiply the x. I want the x's to both be $4.20. So I have to multiply the bottom row by 420. You see, if I multiply 420 times 1, I get 420. I want to get the same number for both. See why I'm doing that? Are you still there? Oh, I'm sorry. So I'm going to multiply. Do you see, I have 420 on top. I have 1 on the bottom. I'm going to multiply the bottom by $4.20. So I have the same number for x. Now, if I have the same number, that's good, but one has to be positive, one has to be negative. So I'm going to multiply the bottom by a negative 420. Negative 420 times x is negative 420x. Negative 420 times y is negative 420y. And negative 420 times 100 is negative 420. Then I still have these. I'm going to just leave it at 420x, 4.20x, and 3 plus 3.10y equals 376. So that was step one. Step two, we're going to add going down. 420 minus 420 turn into 0. 310 minus 420. So $3.10 minus $4.20 equals a negative $1.10 of the y's. 376 minus 420 equals a negative 44. So I have a negative 1.10y equals a negative 44. I want to divide both sides by whatever next to the y, 1.1, divide by negative 1.1, and we'll see what y equals. 44 divided by 1.1, and y equals 40 pounds. Now, I can tell you what x equals right away. Do you see my equation up here? X and y have to add up to 100. If y is 40, what does x equal? Yeah. So you can just say, oh, I can take my original one. Remember, take your original equation, plug the 40 into the y, and then take the 40 over, x equals 60. So the one hamburger is 60 pounds. The other kind of hamburger is 40 pounds. I know that was a lot. It's always a lot of information all at one time. What I do is I'm gonna record this